guys, welcome again in new session of chemistry. In this session of chemistry, I am going to discuss about mole fraction. Let's start. What is mole fraction? The ratio of number of moles of one component to the total number of moles present in the solution is known as the mole fraction of that component. So mathematically, mole fraction of a component is equal to number of moles of the component upon total number of moles of all components. It is denoted by X and a subscript used on the right hand side of X denotes the component. Let us suppose that a solution contains Na moles of solute and Nb moles of solvent. Then mole fraction of solute XA is equal to number of moles of A upon total number of moles of both component, means solute plus solvent. It is equation first. Similarly, mole fraction of B component XB is equal to NB upon Na plus Nb, equation second. The sum of mole fractions of all the components in a solution is always equal to the one as shown below. Equation first and second, XA plus XB, putting the values XA and XB from equation first and second, then Na upon Na plus Nb plus Nb upon Na plus Nb is equal to 1. So XA plus XB is equal to 1. Mean mole fraction of solute plus mole fraction of solvent always is equal to 1. If a solution contains small I number of components, we have X1 is equal to N1 upon N1 plus N2 plus Ni. Similarly, X2 is equal to N2 upon N1 plus N2 plus Ni. And X1 plus X2 plus Xi is equal to 1 always. Very important. Remember it. Thus, if the mole fraction of one component of a binary solution is known, that of the other can be calculated. For example, XA is equal to 1 minus XB. Similarly, XB is equal to 1 minus XA. So I repeat, if the mole fraction of one component of a binary solution is known, that of the other can be calculated. If mole fraction is multiplied by 100, then mole percent is obtained. Thus, mole percent is equal to mole fraction into 100. When put the value of mole fraction, then is equal to number of moles upon total number of moles into 100. So mole percent of component A is equal to mole fraction of A into 100. Similarly, mole percent of component B is equal to mole fraction of B into 100. In vapor phase, mole fraction of a component may be calculated as mole fraction of A in vapor phase is equal to partial pressure of A in solution upon total vapor pressure. Similarly, mole fraction of B in vapor phase is equal to partial pressure of B in solution upon total vapor pressure. It may be noted that the mole fraction is independent of temperature and is unit lash. Very important. Now we take some numerical question for exercise. So question is, calculate the mole fraction of ethylene glycol if 20% ethylene glycol is present by weight in a solution. So solution will be, here 20% ethylene glycol solution means 20 gram solute is dissolved in 80 gram of solvent. So mass of glycol is equal to 20 and mass of water solvent is 80. Molar mass of ethylene glycol is equal to 62 gram mole inverse. When put the value of mass of different elements, then molar mass of ethylene glycol is obtained 62 gram mole inverse. Therefore, number of moles of glycol in 20 gram amount, mass upon molar mass 20 upon 62, therefore number of moles of ethylene glycol is 0.322 mole. Similarly, number of moles of water in 80 gram amount is equal to 4.444 mole. Therefore, mole fraction of ethylene glycol is equal to moles of ethylene glycol upon total mole of the solution. Therefore, moles of ethylene glycol is 0.322 mole upon 0.322 plus 4.444 is equal to 0.068. Similarly, mole fraction of water is equal to moles of water upon total mole. Therefore, mole fraction of water is equal to 0.9322. The sum of the component of mole fraction is equal to 1. Now next question for exercise. What is the mole fraction of the solute in 2.5 molar aqueous solution? Very important. 2.5 solution will be 2.5 molar aqueous solution means 2.5 moles of solute are present in 1000 gram or 1 kilogram of water. Thus, moles of solute 2.5, moles of solvent is equal to 1000 upon 18, mass upon molar mass is equal to 55.6. Therefore, mole fraction of solute is equal to moles of solute upon total moles of the solution. Therefore, 2.5 upon 2.5 plus 55.6, resultant value is 0.043. Now we take some numerical multiple choice type questions. You can solve all these questions yourself after pausing the video. So welcome again in Abhigyan multiple choice type questions series. Question first is, mole fraction of the solute in a 1 molar aqueous solution is option A, B, C and D. So solution will be 1.0 molar aqueous solutions means that 1 mole of solute is present in 1000 gram of water. Thus, moles of solute is equal to 1, moles of solvent is equal to 1000 upon 18 is equal to 55.6. Therefore, mole fraction of solute is equal to 1 upon 1 plus 55.6. Resultant value is 0.0177. So answer will be option B. Now next question. The sum of the mole fraction of the components of a solution is 2, 0, 1, none of the above. So answer will be option C, 1. Now next question, third is, Which one of the following concentrations is not affected by temperature? Molarity, mole fraction, option D, both B and C. So answer will be option D, both B and C. We know that molarity and mole fraction are not affected by temperature, whereas molarity is affected by temperature because it is a weight volume concentration unit. Now next fourth question. A 5.2 molar aqua solution of methanol is supplied. What is the mole fraction of methanol in the solution? Option A, B, C and D. So solution will be here 5.2 molar solution means 5.2 mole of solute methanol is present in 1000 gram of water. Therefore, moles of methanol is equal to 5.2. Moles of water is equal to 1000 upon 18 is equal to 55.6. Therefore, mole fraction of methanol solute is equal to moles of methanol upon total moles, mean moles of solute plus moles of solvent. Therefore, resultant value of mole fraction of methanol is equal to 0.086. So result answer will be option A, 0.086. And last question, fifth is unit of mole fraction is option A, mole kilogram inverse, option B, mole liter inverse, option C, both A and B, D, none of the above. We know that mole fraction is a unitless concentration unit. So answer will be none of the above, option D. It is the unit of molality. It is unit of molarity. So answer will be option D, none of the above. Hopefully guys, you have understood about mole fraction. Thanks for watching the video.